Let's solve path sum on LeetCode. In this problem, given the root of a binary tree and an integer target sum, we need to return true if the tree has a root to leaf path, which is important, root to leaf, such that adding up all the values along the path equals to target sum. So in this example, we have a tree, and in the input, we have target sum is equal to 22. So within this tree, we have to find a path where when we add the values of the nodes that we're on together along this path, it should be equal to 22. In this case, we're going to return true because this path does exist if we follow the blue nodes. So with that out of the way, let's begin coding. So how are we going to solve this? Given that this is a tree, I'm going to solve it through recursion. But what exactly are we going to do? Well, we're going to create a helper function which returns Boolean and takes two inputs as its signature, which is tree node and the target sum which they gave us in the given. So let's begin by writing this helper function, public boolean, we can call it path sum, that takes tree node and int target. The first thing I'm going to do is I'm going to acknowledge the fact that if they give us a node which is empty, we need to return false. So if nodes equal to null, return false. And we can see this in example 3, because if they give us a target sum and we have no nodes in our tree, then obviously we'll never be able to attain that target sum. So how are we actually going to solve this? Well, with the target sum that they gave us, on each node that we're on, I'm going to subtract the value of the node that we're on from target. So in example 1, target sum is 22. The first node that we're on is 5. 22 minus 5 is 17. Then I'm going to check if the node that we're currently on is a leaf node. How am I going to check if it's a leaf node? I'm going to check what it's pointing to the left and what it's pointing to the right. If both these values are null, if both these nodes are null, then the node that we're on is a leaf node. Otherwise, it's not a leaf node. Now the big picture is on every node that I'm on, I'm going to subtract the value of that node from target. And I'm going to keep going until we reach a leaf node and target becomes equal to 0. So here, target minus 5, 22 minus 5 is 17. Here, 17 minus 4 is 13. 13 minus 11 is 2. 2 minus 2 is 0. So once we reach a leaf node and our target, which we keep updating by subtracting the value of the nodes that we're currently on from it, when target equals to 0 and we're on a leaf node, then all we need to do is return true. So let's write these few lines of code. So like I said, we're going to update target to be the subtraction of the original target value from the value of the current node that we're on. So node.val. Then, like I said, I'm going to check if we're on a leaf node. So if node.left is equal to null and node.right is equal to null, we need to return target equal to 0. So if target is equal to 0, it's going to return true. If it's not, it's going to return false. Now the recursive part. So if we're not on a leaf node, then we need to check the left and right nodes. So return path sum of node.left and target, which would be the new updated target from here, or path sum of node.right and target. So we're using an OR because it doesn't matter if both sides have a path that is equal to target once you add the values up. We just want at least one side to, or one path to have their values added up to be equal to target, so we're using an OR. So before we submit, we just need to have a final return statement in this line of code and the main function. So return path sum that takes root and target sum. So let's run our code and see if it works. Awesome. So let's quickly go through an example to make sure we get the point across. Alright, so for the same tree, let's run it through our function to see what happens. So in the beginning, we have return path sum of root and target sum. In other words, of 5 and 22 based on this example. So this is going to call our helper function, and we're going to check if node is equal to null. Is 5 equal to null? No, so we can skip this. Target minus equals node.val. That means 22 minus the value which we're on, which is 5. That's 17. Are we on a leaf node? No, since dot left and dot right are not equal to null, so we can also skip this. And we need to return this line of code. So now node.left is 4, and target is now updated to be 17. And then node.right is 8, and target is 17. So this is going to call our function once again, and we're going to check, is 4 null? No, it's not, so we can skip this. We need to update our target, so 17 minus 4, that's 13. We're not on a leaf node, since although dot right is null, dot left isn't null, so we can also skip this, and we need to call this function again. Now node.left is 11, so our updated target now would be 17 minus 4, which is 13. That's on the left side. On the right side would be null and 13, so null, 13. And we'll get back to this in a bit, but since it's null, this is going to be false. But let's keep checking this for now. So is 11 null? No, it's not. Let's update target. 13 minus 11, that's 2. And now we have to check if it's a leaf node, which it's not. So we're going to return this statement. On the left, we have 7 with a target of 2. And then on the right, we have 2 with a target of 2. So let's see this statement. Is 7 null? No. Update target. Target would be 2 minus 7, which is negative 5. And now we have to check if it's a leaf node, which it is. So we're going to return target. Return is target equal to 0. No, it's equal to negative 5. So that's false. If we check path sum 2 of 2, is 2 null? No. So update target, now it's equal to 0. 2 minus 2 is 0. Is it a leaf node? Yes, since both left and right are null. Is target equal to 0? Yes, it is. So we have to return true. So this is true. So now we can remove these and update them up here. False or true, that's true. So we can remove this, update this, and remove this. And here, since node is null, we just return false. True or false, that's true. So we can remove this, update this. Now you can follow the same set of steps for path sum 8 and 17, but since this is true, no matter what the outcome here is, if it's true or false, our final output is going to be true. So we can just remove this and return true. So that was the path sum problem on LeetCode. I hope you found that video helpful, and thanks for watching.